For this series, we want to use the integral test to determine if it converges or diverges. Okay. For our general term here, the general term an is given by n squared times e raised to n negative n cube. To use the integral test, we let the function be x squared e to the negative x cubed. Just replace n by x. Now we need to show the following three things: f be continuous, positive, and decreasing. All three on this interval. Let's look at the sum, n from 1 through infinity. So we need to show the function satisfies these three things on 1 through infinity. Okay, so we have a product of two functions, x squared always positive, exponential function, this is also x squared continuous and positive, exponential function also continuous and positive. Regardless of this negative, exponential functions are always positive. Okay, always positive, and they are continuous as well, and the product of two continuous functions is also continuous. So no questions on these two things. Next, we need to show f is decreasing. For we find the derivative, use product rule combined with chain rule obviously, and show the derivative is less than 0 on the interval 1 through infinity. Then we can say f is decreasing. But instead of doing that, let me try to argue this way. Okay, x squared times e to the negative x cube can be written as x squared, let me get rid of this negative exponent, over e x cube, right? And when x is very big, this bottom gets bigger than the top, x squared ex cube. This function ex cube grows faster than x squared. That means this function is decreasing. Okay, this function is decreasing. So this is also true. Now we find the improper integral of this function. Let me write in this way: ex squared over e x cubed from 1 through infinity. We find this improper integral. If this converges, this series converges, and vice versa. Okay, to evaluate this improper integral, we need to take the limit, because infinity 1 through t. Let the limit t goes to infinity of x squared over e to the x cubed dx. Okay, that is limit t goes to infinity. How to find the antiderivative of this fraction x squared x cubed? By the way, what is the derivative of x cubed? Let's say this is u. Derivative of x cubed is 3x squared. We don't have 3x squared, but we have x squared. So multiply by 3 and divide by 3. That makes e to the u on the bottom. Let me write over here, e to the u on the bottom, and derivative of u, which is 3x squared, that's on the top. So 1 du, or du just, okay, or u prime, or we write 3x squared dx is du. So it becomes 1 over e to the eu du, and we know how to integrate this. How? E to the eu du is same as e to the negative u du, and when we integrate, this becomes e to the negative u divided by this negative 1. Okay, so this is the antiderivative we're going to use over here. It's kind of double u substitution. Okay, 1/3 we can pull all the way outside, and antiderivative of 3x squared over ex cubed, because the derivative of x cubed 3x squared dx, that's du part. So let me write one more line, 1 to t 1 over EU 3x squared dx is du, where u is x cubed. 1/3 limit t goes to infinity, antiderivative of 1 over EU in this way, e to the negative u on the top, and we get negative 1 e to the negative u, and we want to evaluate from 1 through t and let t go infinity. This negative 1 can be pulled all the way outside, negative 1/3 limit t goes to infinity, e to the negative u, that is same as 1 over EU. Okay, let's work on positive exponent, and we want to evaluate from 1 through t. Negative 1/3 all the way outside, limit t goes to infinity. Let's replace u by t. By the way, u is, sorry, what is u? U is x cubed. Okay, let's replace u by x cubed. So e raised to t cubed, 1 over e raised to t cubed, that's the upper limit, minus lower limit, replace x by 1. So 1 over e to the 1 cube is 1, so e to the 1, so 1 over e, which is a finite number, decimal number, 1 over e. Negative 1/3, when t goes to infinity, t cube goes to infinity, e to the infinity, e raised to infinity is infinity, e to the very big number is very big, and 1 over very big is 0, minus 1 over e, it does not have t, so just 1 over e, and 0 minus 1 over e is just negative, negative positive, 1 over 3e, so basically 1 over 3e, which is a decimal number, which is a finite number. All it matters is finite number. That means this improper integral converges, in turn this series converges.